A-7 Corsairs, F-14 Tomcats, A-6 Intruders, and F-4 Phantoms are all modern warplanes, but they are all members of a special breed. Instead of operating from land airfields, they are carried in or on an airfield that goes to sea. A floating city with a population of over 6,000, the giant carrier is the biggest and most expensive kind of warship in history. And though it has few weapons of its own, the carrier's striking power is many times greater than that of the biggest battleship. Its real power resides in its aircraft. The F-4 Phantom, for instance, became operational with the U.S. Navy in 1961. Yet, even in the mid-60s, here, looking astern from the USS Forrestal, it was still quite a new shape in the sky. Noted for its smoky J-79 engines, an F-4B comes in at a steady 150 miles per hour and slams onto the deck. These Phantoms belonged to Fighter Squadron VF-74, the Bedevilers, which was the first F-4 unit to join the Atlantic Fleet. The detailed pre-mission briefing is usually a model of routine efficiency. This is followed by the flight crews completing the process of donning survival equipment over their flying suits. At the correct time, the flight crews go topside and proceed to their aircraft. Each flight crew takes care to check its airplane and its ordnance, and then they board their Phantom. The exact launch weight of the aircraft is chalked up for the catapult control team. The Phantom was the last airplane to need a giant bridle to connect it to the shuttle of the catapult. The bridle pulls the Phantom from two strong forgings under the roots of the wings, and though it costs many hundreds of dollars, it is used only once, because it goes into the ocean at the same time as the airplane goes into the sky. With canopies closed and checks completed, the Phantom taxis to the allotted catapult. There are 4 catapults, 2 at the front of the angled deck and 2 leading straight over the ship's bow. After the previous launch, the solid steel shuttle is sent back to its starting point. The flight deck director positions each airplane for launch. In the case of the F-4, the twin nose wheels have to pass over the shuttle and drop back onto the deck. The bridle is looped over the shuttle and its rear hooks secured to the Phantom. The shuttle is then inched forward to take up the slack. while the Phantom's nose gear is extended to its full height to jack the airplane up to takeoff attitude. With all checks complete, the deck director signals the pilot to run up to full afterburning thrust. In seconds, the power is on. The director drops to one knee and points down the deck. The shooter presses a button, and the CAT controller fires the catapult. The catapult, powered by steam under tremendous pressure, develops such brutal thrust that in 2.5 seconds, and in a run of just 200 feet, it can fling a loaded airplane off the ship at full flying speed. As soon as the aircraft have gone, the next pair are ready. As they taxi into launch position, large deflector panels are raised to protect the aircraft behind from engine blast. Once again, back comes the shuttle. Over goes the nose gear. In comes the bridle. And up goes the nose as the nose leg extends. It's all done in seconds, and nothing is forgotten. In this case, 4 aircraft, 3 F-4Js and an A-4 are launched almost simultaneously. During the launch cycle, more airplanes come up to deck level on the 4 huge elevators. Everything possible is done to maintain the rhythm of launching groups of aircraft, in this case, 3. The result is perhaps 30 or 40 aircraft going about their business, protecting the battle group, searching ahead for submarines, maintaining radar surveillance, and flying many other kinds of mission. At the end of each mission, the aircraft are handled by air traffic control and fed into the landing approach pattern. The approach has to be right in attitude, height, rate of descent, engine power, and obviously in keeping exactly lined up with the flight deck. This is complicated by the need to line up with a deck mounted diagonally across a ship that is moving at high speed through the sea. The one favorable feature is that, if possible, the carrier is steered so that the wind is blowing straight down the angled deck to assist the landing. Every arrival is studied through binoculars to check that the landing gear, flaps, air brakes, hook, and wing sweep are in the correct configuration, and the aircraft is then talked down by the LSO, or Landing Signals Officer. The pilot tries to grab number 3 wire, and the latest fighters hit the wire at over 150 miles per hour.
Okay on 3. Highest ramp on 5.
For the pilot, this is a time for real concentration. He keeps his eyes on the meatball, the bright amber light on the right of the landing area. The meatball must be exactly lined up with green lights on each side of it. This pattern of lights is set to a different height and angle for each aircraft type. Once the LSO has given the OK with the words "clear deck," meaning the previous plane is out of the way, the next man can come in. During the approach, the LSO, a veteran pilot, talks the incoming pilot down, mostly giving reassurance, but instantly warning of any departure from a good landing. In the worst case, the LSO waves the pilot off for a second attempt. As soon as the aircraft comes to rest, The deck crew rush up and remove the cable from the hook. The plane taxis forward out of the way, and the crew disembark. Often, after recovery back on deck, an aircraft is struck down below for maintenance. Simple jobs can be done on deck, but all heavy maintenance has to be done in the hangars. The giant U.S. carriers have 3.5 acres of hangar, enough for about half the carrier's complement of aircraft. The biggest and latest U.S. carriers can carry over 90 aircraft. The flight deck, compared with a land air base, is very small. Therefore, every movement on deck has to be choreographed as accurately as a ballet to move everything to the right place at the right time. To see a great carrier at work is like watching a huge, well-oiled machine. Aircraft are fueled, loaded with quadruple launchers for Zuni rockets and with Mark 82 slick general-purpose bombs. All is made ready for the careful walk-round inspection undertaken by each pilot. His entry into the cockpit is accurately timed. Everything aboard the plane must work, or it will miss its launch slot in a busy schedule. The USS Enterprise, CVN-65, demonstrates the launch of different aircraft from her 4 powerful steam catapults. First, an F-4J Phantom. Next, an A-4 Skyhawk on a practice attack mission. Then another F-4 to join up with the first. And finally, a mighty R-5C Vigilante for a far-ranging reconnaissance mission. Navy A-4s were particularly active in Vietnam, such as here at Tan Linh, where they are peeling off in succession. Such attacks were tight on timing and tight on fuel, but every man tried to put his ordnance dead on target. The left turn becomes a half roll to the inverted position, followed by an almost vertical dive to ensure maximum accuracy. Nothing pleased the pilot more than to hear the forward air controller exclaim, "You got him." Undoubtedly, the #1 naval warplane of the Vietnam War was the Phantom, often armed with the AGM-12 Bullpup air-to-ground missile. Even early versions of the Phantom could carry 4 Sparrow and 4 Sidewinder air-to-air missiles. They were equipped with an outstanding multi-mode Westinghouse radar and an advanced bomb aiming system. Wisely, the Phantom was given a crew of 2. The pilot in the front cockpit had his hands full with flying the airplane and with selecting and arming the attack weapons. He was also busy keeping a constant lookout for other aircraft, especially hostile ones. The radar intercept officer in the rear cockpit would spend most of his time in the battle area monitoring the tactical situation as seen on his radar display and in advising the pilot on what was happening. The F-4 Phantom, in many versions, was one of the few aircraft to serve in Vietnam in both the fighter and attack roles, and there was also a reconnaissance variant. Occasionally, the 580-pound Bullpup radio command guided missile was used, as in this attack on a barge just off the coast of Vietnam. Eventually, much of Vietnam became covered with craters, mostly made by 500, 750, and 1,000-pound bombs. Of course, there was always plenty of flak coming the other way. Small arms fire was usually intense enough to prevent airplanes flying below about 3,000 feet, unless there were special reasons. Aircraft often had to come low in spite of especially intense fire to hit the vital Tan Ho and Paul Doomer bridges in North Vietnam. One weapon used against the bridges by the Navy was the Walleye television-guided glide bomb. At the end of a mission, nothing seemed better than to have one's wheels slam brutally onto the friendly deck and to feel the colossal pull of the arrestor cable. One of the best-loved fighters in the Navy was the Vought F-8 Crusader. It was the first supersonic aircraft to be based aboard carriers in 1957, and was faster and had longer range than the Air Force's F-100 Super Sabre, though fitted with the same engine. The F-8D version, fitted with retractable in-flight refueling probe, was the fastest of the F-8s, with a speed of 1,230 miles per hour. Early F-8s had an armament of 4 20mm cannon and 32 rockets. Later versions added 4 Sidewinder missiles on the sides of the fuselage and a better radar. Finally, provision was made for up to 5,000 pounds of bombs, rockets, bullpup missiles, or other air-to-ground ordnance. Typical practice bombing missions were flown, usually in a shallow dive. The pilot used the gun sight in the depressed reticle mode to aim the bombs at the target. Another ground attack weapon was the 5-inch Zuni rocket. Up to 24 Zunis could be fired from 6 underwing pods. Though unguided, these rockets could bring down a massive barrage on enemy troop concentrations. It was said that ripple firing 24 Zunis was roughly equal to a broadside from a battleship. If necessary, to restore full air combat performance, the empty Zuni launchers could be jettisoned, though they were usually brought back for refurbishing. A unique feature of the F-8 was that the wing was pivoted on the fuselage and could be set at a high angle for maximum lift, while the fuselage was level or even slightly nose down, to give the pilot a good view ahead during carrier landings. Until December 1978, Britain's Royal Navy deployed conventional fixed-wing air power at sea. Once the Royal Navy had a large fleet of carriers, but in 1978 there was just one, the Ark Royal, and its chief strike aircraft was the Buccaneer.
042.
The requirement which led to the Buccaneer was drafted as long ago as 1952. It was so far-sighted that it called for the ability to attack at the lowest possible level, approaching under the beams of hostile radars, which is a present-day tactical requirement. Crewed by a pilot and navigator, the Buccaneer has proved to be a most valuable aircraft, with sufficient fuel for far in excess of the specified combat radius of 400 miles.
Leveling out. Okay.
Without using the in-flight refueling probe above the nose, it can fly well over 2,000 miles, and what's more, it can carry 4,000 pounds of bombs faster at low level than any other aircraft, about 695 miles per hour.
Down you go. Okay.
That's because the bomb load can be stowed in an internal weapons bay. If necessary, a further 12,000 pounds can be hung on wing pylons, or alternatively, these pylons can be used for Martel ground attack missiles or Sea Eagle anti-ship missiles.
I've got the landfall. Starboard
The projection at the tail is a pair of powerful air brakes which open out sideways on landing. Buccaneers have now been in service for 25 years and are being completely upgraded and fitted with improved radar and other updated avionics. All surviving Buccaneers now fly from the Royal Air Force's land air bases, though they are often tasked with maritime and coastal strike missions.
Okay, I see the lakes. Selected. Roger.
Most observers consider it was a costly mistake for Britain to have phased out her conventional carriers. This is a Vought A-7 Corsair II, an airplane we have seen already. Like all good designs, the A-7 was progressively improved, and this is the ultimate carrier-based version, the A-7E. Its most important difference is that it is now fitted with a much more advanced navigation and weapon system. In this, a computer integrates the inputs from an inertial navigation system, a Doppler radar, a main forward-looking radar, a radar altimeter, and today, a forward-looking infrared pod hung below the right wing. Corsairs can carry a wide range of ordnance, including the AGM-45 Shrike anti-radar missile, which homes onto hostile emitters. Another option is the AGM-65 Maverick, which can be guided by TV, infrared, or laser, and which has a good reputation for hitting its target. With the FLIR, forward-looking infrared, the A-7E has excellent ability to find and attack targets at night or in bad weather. Corsairs are flown by many Navy and Marine light attack squadrons, operating from carriers such as USS America. Though the big flat tops operate their own early warning and reconnaissance aircraft, additional and vital information is provided to the carrier battle group by land-based maritime patrollers. Most have been derived by converting civil airliners, but the European Atlantique was designed from the start for the ocean patrol and ASW, anti-submarine warfare missions. Features include a long wingspan, two 6,000 horsepower Rolls-Royce turboprop engines, and a spacious pressurized fuselage. There is plenty of room for the crew of 12, and a complete spare relief crew is carried for improved efficiency during an 18-hour mission. Atlantique is fitted with a black retractable radome deployed below the forward fuselage. In the nose is a visual search station. But the Atlantique's most important single task is ASW, and here the main sensor is the powerful radar. Atlantique also carries more than 100 sonobuoys of both passive and active kinds, which, with flare and smoke markers, fill most of the rear fuselage. Also vital is a MAD, a magnetic anomaly detector, in a long boom projecting behind the tail. ESM, electronic support measures, are also comprehensive.
Toulac, right, 240, TAC 015. Route 170, 26
The FLIR turret gives almost perfect thermal pictures for night and adverse weather operations. Infrared is particularly useful in sea control and search and rescue missions. There is a large weapons bay and 4 underwing hardpoints for a wide range of ordnance. A typical internal load might be 3 ASW torpedoes and an Exocet anti-ship missile.
Attention pour attaque.
8 Mark 46 torpedoes can be carried. Surface ships can be destroyed by first feeding in their target coordinates and then firing an Exocet missile. This can hit a target out to about 35 miles. Britain's counterpart is the Nimrod, the biggest and most powerful of all current maritime patrol aircraft. Among its impressive array of sensors is a 70 million candle power searchlight out on the starboard wing for use in sea control and search and rescue missions at night. Under the rear fuselage are hinged flaps covering vertical reconnaissance cameras. The crew can also aim handheld cameras from bulged observation windows. The main sensor is the searchwater radar in the nose. Almost every kind of sonobuoy can be carried, and Nimrod is fitted with a MAD in the long tail boom and electronic support measures on top of the vertical tail. The internal weapons bay is the biggest of any maritime aircraft, and it can carry a vast range of torpedoes, depth charges, mines, and other stores in 6 rows, one load including 9 torpedoes. Nimrod has a large crew, a flight crew of 5, and a tactical crew of 6 or 7. The Nimrod MR2 is extremely popular with its crews, for it gives a much quieter and smoother ride than propeller aircraft, and can accomplish more in a shorter time.
On neon and lights.
Director horizons.
Director fail flags, director indices, parked.
Right, carry out steer checks when required.
Powered by 4 Rolls-Royce Spey turbofans, Nimrod is much faster than other oceanic aircraft and can get out to its patrol area at 575 miles per hour, even though it weighs twice as much as an Atlantique and is 130 feet long. Unlike other maritime aircraft, it can hold station at a radius of over 1,500 miles for as long as 5 hours. Once on station, the flight engineer shuts down 2 of the engines to conserve fuel. Range and endurance can always be extended by in-flight refueling, another unusual feature for an ocean patrol aircraft. The searchwater is probably the best radar in the world for locating and identifying targets in rough seas. Target bearing and range is automatically fed into the main computer and is also shown on the tactical display. There is also a separate display for routine navigation. In the rear fuselage are the stores of sonobuoys, more extensive than in any other aircraft. They include the Australian Barra, Canadian Tandem, American Buoys, and the ultrasonobuoy, with performance similar to helicopter dipping sonar. The computers record which launchers are ready to fire. Meanwhile, another crewman is studying the pen chart fed by the MAD. As soon as a contact is obtained, a smoke marker can be retrofired so that the spot is accurately marked. Within minutes, a single aircraft can close the net around a target submarine. At the exact moment, Nimrod can release a parachute-braked anti-submarine torpedo, such as the new Stingray. The patrol aircraft can instantly transfer its entire tactical plot to a relieving aircraft. The U.S. Navy's shore-based patroller is the PC-3 Orion, powered by 4 turboprops. At the start of a patrol, during takeoff, the 4 throttles are held wide open, with all 10 crew on board ready at their posts.
Here we go. Roll. Push power normal rated. Right.
The P-3 can patrol for 3 hours at a radius of 1,500 miles. Like Nimrod, it can conserve fuel by shutting down 1 or even 2 engines after arrival on station. As usual, the P-3 has radar, ESM gear, and a mad stinger in the tail. But in the ASW role, the chief sensing technique is underwater acoustics, using sonobuoys whose outputs are analyzed by advanced processing electronics. Sonobuoys can detect the precise acoustic signature which betray the presence of a submarine, which is immediately reported to the aircraft. Next, the threat library of acoustic traces is compared with the new, unknown trace to identify the actual type of submarine. Sometimes the crew are skilled enough to identify an individual submarine that they may have met before. Occasionally, submarines are spotted on the surface.
Roger, got him. Tally-ho, 11:30 just left of the nose.
All sonobuoy data, like that from other sensors, is fed to the main computer. Humans could never begin to handle the amount of information received, and so the computers compile and constantly update the stream of data.
Roger, stand by. It's about 15.
DC can search by weapons.
Roger, search bar. Got search bar?
Roger, we'll be executing a line pattern here in a second to have flight difference.
Liners installed, sir. Standing by with the smoke. And give me a down on top flight. Roger, stand by. About 10 seconds. And it looks like he's getting ready to go down. He's going to be going down on it. 5 seconds. Mark on top. Now.
Each P-3C can carry up to 10 tons of weapons in a shallow internal bay and on 10 underwing pylons. The load can include 8 anti-submarine torpedoes and 3 nuclear depth charges. Up to 6 Harpoon cruise missiles can also be carried for attacking surface vessels. Like other patrol aircraft, the P-3's duties range from putting down a geometrically correct barrier pattern of sonobuoys to humanitarian search and rescue, or police duties such as offshore surveillance and anti-smuggling missions.
Section 3, we have a small light, 10 o'clock, about 7 or 8.
For such duties, the FLIR turret under the nose really comes into its own, presenting the crew with clear pictures of objects of interest at night or in bad weather. Every bit of data gathered by the sensors can be transmitted to a shore base, a friendly ship, or another P-3C, and in any case, everything is recorded on tape for subsequent analysis and for updating threat libraries.
Sensor 3 flight, be sure to get this on ERDS film. And TC, are you taking a look at this contact?
Roger, flight. I'll make sure intelligence sees this.
Though powered by turboprops, the P-3 is not slow, for it is comparatively light and has a maximum speed of 473 miles per hour. By 1988, the U.S. Navy had already defined an Update 4 for the P-3C, with ESM passive detectors in wingtip pods, and is presently engaged in studying a next-generation replacement aircraft. Elevators bring SH-3 Sea Kings up to the flight deck. Even on big carriers, there is plenty of work for helicopters. It takes only minutes to unfold the 5 blades of the main rotor, to fire up the engines, and depart on a patrol mission. In the ASW role, the Sea King normally carries 2 torpedoes. Its chief sensor is a dunking sonar, which is lowered into the water to detect submarines by active or passive means. If a contact is obtained, its position is fixed by a smoke marker. Sea Kings can remain on station for over 3 hours, but mission endurance can quite simply be multiplied by taking on fuel from a friendly ship in the helicopter's own battle group. Sea Kings have been flying almost 30 years, and the U.S. Navy now has a next generation, also from Sikorsky. It is the SH-60 Seahawk, a totally revised version of the Army's Black Hawk troop carrier. Powered by two 1,690 horsepower engines, the Seahawk is big, complex, expensive, and very capable. The initial type, now in wide service, is the SH-60B for use from destroyers, frigates, and cruisers in the ASW and anti-ship surveillance and targeting roles. ASW sensors include a battery of 25 sideways firing sonar buoys. A MAD is carried in a brightly painted bird trailed on the end of a cable. As usual, the main weapons comprise two ASW torpedoes. These may be the new Mark 50 type, braked by parachute. Besides the sonar buoys, a radar and infrared sensor are also carried. Special tests were undertaken of the ejector system where all 25 sonar buoys were rippled away indiscriminately. To permit such a big and costly machine to operate from small, slippery decks, which may be rolling and pitching in a gale, the RAST, Recovery Assist Secure and Traverse System, is used. This links the helicopter and ship by cable, hauls the helicopter down against the upward pull of the rotor, secures it to the deck, and then guides it into a hangar. Also built by Sikorsky, the MH-53E Sea Dragon is the Navy's biggest helicopter. On each side, it has a giant streamlined tank which extends mission endurance to more than 6 hours. The lifting power of its 7-blade main rotor with 13,140 horsepower behind it is immense. The Sea Dragon is an MCM, or Mines Countermeasures aircraft. The large fuel tanks are needed because during each mission, its 3 engines have to run at constant high power, as the helicopter is attached to any of a series of giant mine-sweeping sledges. These have to be pulled through the sea and also supplied with electrical power. Each sledge is supported on hydrofoil blades and clears or detonates mines by mechanical impact or by magnetic, acoustic, or pressure influence methods. Here, the Sea Dragon is towing a Mark 166 magnetic influence sledge. In combat duty, a 4-hour mission is more usual, but it can always take on more fuel via an extendable flight refueling probe. Despite the cost, France still operates 2 conventional carriers. The main French naval attack aircraft is the Super Étendard, famous from its use by Argentina during the Falklands War. It is easy to fire off the deck because it is quite a small aircraft. Where it does pack a punch is in the AM-39 Exocet anti-ship missile, which knocked out the British destroyer Sheffield with a single hit. Usually only one missile is carried. The Super Étendard is the only known non-US jet currently operated from conventional carriers with CAT launches and arrested landings. Less glamorous than a dedicated strike aircraft, but still doing a vital job, the Lockheed S-3 Viking is the U.S. Navy's standard embarked ASW, anti-submarine warfare aircraft. To do its job, it has to package into one small airframe a flight crew of 2, a tactical crew of 2, a radar, MAD gear, and a mass of sonobuoys and acoustic subsystems. It also has an FLIR turret, comprehensive navigation and weapons delivery systems, a heavy load of anti-submarine weapons, a large electronic support measures installation, a high-power computer, and cockpit displays, and fuel for 12 hours. The chief ASW sensors are, as usual, the sonobuoys. These are laid to form a barrier through which a hostile submarine may pass. The types and positions of each buoy appear on the tactical display, and the sensor operator and tactical coordinator can call up from the computer memory a threat library of the acoustic signature of hostile submarines and thus identify the actual type of each submarine detected. The vast array of highly sensitive equipment on board nevertheless has to remain serviceable despite repeated catch shots and harsh, arrested deck landings. Radar and acoustic data from each mission can be transmitted in real time back to the carrier. It is also stored on tape for subsequent analysis and, for example, to update the fleet's threat libraries. As the threat develops, it is studied by the TAC coordinator in the Viking and also relayed to the carrier command centers, where major assets can be allocated.
Combat, we've confirmed 704's contact.
Roger, SW, thank you. Flag, TAO.
The carrier's tactical air officer can, for instance, issue orders to harden the battle group's defensive screen.
Admiral Flag, TA.
The S-3's economical turbofans burn little fuel at the 160 knots loiter speed, but can immediately slam to full power, turning the long span machine into a surprisingly agile foe. The ESM pods on the wingtips listen to all hostile emitters, such as weapon guidance signals, radars and communications, and feed the locations and types of each source into the tactical plot. The mad boom can be seen extended behind the tail, where it can detect small anomalies in the Earth's magnetic field caused by a submerged submarine. Up to 7,000 pounds of ordnance can be carried in the weapon bay and on 2 wing pylons. Stores can include nuclear and general-purpose bombs. Mines and rockets can also be used. ASW torpedoes are usually carried for naval attacks, as are Harpoon anti-ship cruise missiles. As if 12 hours were not enough, the mission can be extended by plugging into the refueling drogue trailed by a KA-6D Intruder tanker. Back on station, the Viking can resume its task of tracking, comparing acoustic signatures, and identifying hostile subs. The combined information from the different sonar sources give range and direction of the target, and the net can be quickly closed. At the end of its allocated patrol time, the S-3 recovers in an arrested landing, folds its slender wings and parks, while its tired crew go to their debriefing. One of the longest operational careers is that of the Grumman A-6 Intruder. Introduced in 1965 at the same time as Britain's Buccaneer, and designed to fly the same mission, it is likely to fly on to the end of the century. For many years, the standard aircraft has been the A-6E, powered like its predecessors by 2 J-52 turbojets, but progressively updated in avionics. Unlike the Buccaneer, the A-6E carries all its weapons externally, up to 18,000 pounds being theoretically possible on 5 hardpoints. Another difference is that the crew of 2 sit side by side, the bombardier navigator being slightly to the rear and at a lower level than the pilot. Capability at night and in adverse weather has been vastly enhanced in some A-6Es by adding a tram turret, meaning target recognition and attack multi-sensor, under the nose. This stabilized turret contains an FLIR sensor and a laser spot detector, which automatically indicates any point on the ground illuminated by a friendly laser designator. Boeing is supplying new carbon fiber wings for an initial batch of 102 A6Es and may re-wing the entire fleet. A possible total of 150 new A6Es are to be built by 1995, and throughout this period, the whole force will be updated, keeping them in the front line. Though all it seems to do is cruise around at up to 30,000 feet and try to avoid any kind of trouble, many people aboard U.S. carriers would say that the E-2C Hawkeye was the most important plane on the ship. It is the Navy counterpart of the land-based AWACS, or Airborne Warning and Control System. Much of the tube-like fuselage is filled with a powerful surveillance radar and radar processing system. The main radar antenna is mounted on a pylon in an aerodynamic 24-foot diameter rotodome. Orbiting some 200 miles from the battle group, the Hawkeye's radar can see at least 230 miles, and its passive detection system can identify hostile emissions out to about 400 miles. The processing system analyzes friendly and hostile land, sea, and air targets within a volume of 3 million cubic miles, picking out up to 300 selected targets and simultaneously directing friendly fighters to 30 intercepts. The Hawkeye does not only manage and enhance the defense of the fleet, but it also controls attacks by Hornets and Intruders, for example, increasing accuracy and reducing losses.
Here, I believe I hold a bogey about our 308 142 at this time. Oh, Roger, I've got him. Control.
Continually being updated, the Hawkeye is popularly called a force multiplier because it enhances the capability of every aircraft in the carrier battle group and of friendly surface ships as well. The brilliant Sea Harrier jet, which can fly off very small deck areas, stemmed from an airplane first flown in 1960, which pioneered the simple concept of having a powerful turbofan engine with 4 nozzles, which can be directed backwards for thrust, downwards for lift, or slightly forward for reverse thrust. It was soon shown that the Sea Harrier was a viable proposition, able to operate from a small deck without any catapults, arrestor wires, or landing aids. And what's more, it can do it around the clock in a blizzard or fog, or other conditions that would reduce a huge, expensive carrier to a complete standstill. Both ashore and embarked, it is usual to make a VL, a vertical landing on a designated spot. One advantage of the Sea Harrier is that it is very small. 4 can move about the small hangar and on the elevators of Britain's Invincible-class ships without needing to fold their wings. The aircraft's nose radar, Blue Fox, proved effective in terrible conditions in the Falklands War, both for surface attack and air interception. In the forthcoming Sea Harrier FRS-2 update, it is being replaced by a bigger and more powerful radar, the Blue Vixen. With a lightened load, Sea Harrier can rise vertically from the deck with nozzles at 90 degrees and then transition into forward flight. In 1977, the British developed the ski jump. This is an upcurved end to the deck, so that as the aircraft makes a rolling takeoff, it leaves the deck in an arching upward trajectory. This imposes no penalties and makes it easier and safer to take off at maximum weight with less headwind. One of Sea Harrier's main weapons is the recently developed Sea Eagle cruise missile, which, with its large warhead, can cripple surface ships with a single round. The shriek of F404 engines announces the FA-18. Named the Hornet, this is the newest combat aircraft in the U.S. Navy, and it is exciting in every way. A Hornet in low visibility gray lines up on the catapult. The twin rudders automatically tow in towards each other. This increases drag but has the effect of putting a big download on the tail, raising the nose and keeping the airplane flying as it comes off the end of the flight deck. The barrier comes up. The engines slam into maximum dry power, and with an urgent scream, the Hornet is flung off the bows and into the sky. The Hornet has a massive nose gear, stressed to take the pull of the catapult on a nose tow bar. With the tow bar, there is no need for the flight deck crews to wrestle with a bridle. Again, Hornet is flung into the air, and with light loads, there is no need to select full afterburner. Hornets were ordered by both the Navy and Marine Corps, and they were designed to be equally good at both the attack mission, replacing the Corsair, and the fighter mission, replacing the Phantom. As the Hornet hits the deck, the note of the engine suddenly changes, because this is one of the most responsive engines ever made, and that's important for carrier operations. In contrast, the mighty F-14 Tomcat was for almost 15 years troubled by its engines, but today, while the original TF-30 engine is now turning in a good performance, the F-14A Plus and F-14D are powered by the very much more powerful F-100 engine. F-14As fly with Navy Fighter Squadron VF-84. With the TF-30 engine, every cat shot has to be in full afterburner. Despite its great size, the F-14 is a most agile fighter, its pivoted wings being automatically positioned by a computerized program for maximum flight performance up to Mach 2.34. No other fighter has the M61 gun, Sidewinder dogfight, Sparrow medium range, and the mighty Phoenix long-range missile. Each F-14 can pick out 6 hostile aircraft at a range of over 100 miles and fire 6 Phoenix at them from that distance. Each Phoenix is guided to its own target. The AWG-9 weapons control system can pick up hostiles at ranges out to 195 miles, pick out 24 individual targets, track them continuously, and automatically select the 6 posing the greatest threat. It can then assign a Phoenix to each of these. In the first part of its flight, each missile is guided by the F-14. But as it nears its target, it switches on its own small active radar so that its accuracy increases the nearer it gets. The targets can be aircraft or supersonic missiles arching up to over 100,000 feet, or sea-skimming anti-ship missiles flying just above the wave tops. A crucial role in each interception is played by the radar intercept officer in the back seat. AIM-7 Sparrow missiles, AIM-54 Phoenix missiles, and 675 rounds of 20mm ammunition for the M61 gun are loaded into the left side of the fuselage. Each Phoenix missile weighs over 1,000 pounds and costs over $1 million. The Phoenix has been improved over the years, and so has the F-14. Today's F-14D has completely upgraded avionics, including new cockpit displays. Other improvements include the new Martin Baker Navy ejection seat and the F-110 engine, which not only gives much more power, but also burns so much less fuel that combat air patrol time is extended by 35%. Also, deck-launched intercept radius is extended by an amazing 60%. At the end of each mission, it is the same routine. Wings forward and slats and flaps down, gear down and hook dangling, get in the slot, watch the meatball, and listen to the reassuring voice of the LSO. Never, never watch the deck until you feel the 50-ton pull of the wire. It's a brutal sequence, a challenge for skilled men and for costly hardware, but the Navy has made it into a safe, routine operation. It goes on around the globe aboard 15 of the greatest ships in the world. Each of these mighty carriers is home to 6,500, the center of a carrier battle group which can move 500 miles in a day. Its F-14s rule the sky, its A-6s rule the surface, its F-A-18s can do both, and its E-2Cs warn of foes and guide friends.
Sensor 1, I believe I am. We're depressurized. Okay, get the free-fall chute ready. We'll be putting diapar 15, diecast 2 way on top, out of smoke. Roger, diapar 15 and diecast. Tackle sensor 1, I have contact on diecast 2. Ready.
The area covered by a carrier battle group is huge. If a carrier were to be in Washington, D.C., its escorting frigates and guided missile cruisers would be as far apart as Pennsylvania, the southern part of Virginia, or West Virginia. its patrolling F-14s and E-2Cs would be searching the skies over Maine, South Carolina, Kentucky, and Michigan. Its S-3 Vikings would be sub-hunting far ahead in Ohio, while its A-6E Intruders would be hitting targets in Missouri or Illinois. A 6th Fleet carrier could cover the entire central and eastern Mediterranean and surrounding countries. In Northern Europe, the same battle group could embrace Finland, the Western Soviet Union, Poland, Czechoslovakia, East and West Germany, and almost all of Western Europe. Its escorting cruisers can fire standard missiles. The carrier itself has close-in defense with Sea Sparrow missiles. In the past, the symbol of global power was the proud galleon, or the awesome battleship. Today's power at sea is deployed by mighty ships with flat tops.
On January 4th, 1989, two U.S. Navy F-14 Tomcats flying a routine patrol over the Mediterranean were unexpectedly challenged by a pair of Libyan MiG-23 floggers. Was this a hostile confrontation? At that moment, there was no way to know. The Libyan MiGs were still 70 miles away. Following strict orders to avoid combat unless absolutely necessary, the Navy F-14 pilots turned to avoid the MiGs. Normally, the MiGs would have followed suit. But on January 4th, the Libyan MiGs chose instead to maintain a collision course with the U.S. Tomcats. 5 times the U.S. pilots veered their jets away. 5 times the Libyans mirrored their every move. Closing at incredible speeds, the Tomcats and MiGs ultimately clashed in a supersonic dogfight. In the end, both MiGs were destroyed before either could fire a shot. What you're about to hear and see is the actual video recording of that showdown, just as it was seen by the pilot of the lead U.S. F-14. With today's supersonic fighters, pilots must rely primarily on highly sophisticated radar. As you will see, the enemy MiGs come into sight only in the last moments of battle. Here is the official Defense Department recording from the F-14s. Visual contact is about 6 minutes away. The camera activates at a distance of 30 miles. Now, prepare to see and hear the shoot-down over the Mediterranean as if you were there in the cockpit.
Gypsy 207, contact 175, 72 miles. Looks like a flight of 2, Angels 10.
Close out curves showing 78 miles.
Throttle back just a little bit here.
Cam's close out shows 25 mile separation, turn inbound.
Contacts appear to be heading 315 now, speed 430, Angels approximately 8,000.
Roger, Ace, take it north.
We have to make a quick loop here.
Starboard, I'm going to give you collision here.
Okay, come starboard about 40. (207), 61 miles now, bearing 180. Angels 8, heading 330. Steady up.
Alpha Bravo is closed out.
Come back port 20 degrees here. He's jinking now at us. Okay, bogies appear to be coming jinking to the right now, heading north. Speed 430, Angels 5,000 now in the descent. Okay, let's take her down now. We're going down.
Okay.
Slows out 53 miles now. Bogies appear to be heading directly at us. I'm coming port. Steady up 150 for 30-degree offset. 50 miles. (49 miles now, speed 450, Angels 9. I'm going down to 3.
Crossing back over.
Roger.
Roger that. 30-degree offset now. Bogies heading 340, speed 500. Let's accelerate.
Okay, they look like they're at 9,000 feet now.
Roger. Bogies have jinked back into us now. Let's come starboard 30 degrees the other side.
Coming starboard. Say they're Angels. Hands join up, set station.
Roger. Angels now 11. Steady up.
Close out, warning yellow, weapons hold. I repeat, warning yellow, weapons hold. Alpha Bravo out.
Roger,
Okay.
Gypsies. Pass up, Bravo directs, warning yellow, weapons hold.
35 miles here.
Roger that. Bogies have jinked back into me now for the third time. Nose is on at 35 miles. Angels 7.
Alpha Bravo closed out, you copy?
Okay, I'm taking another offset, starboard 210.
The guy got locked up, Leo's is 30 miles and he's at 13,000 feet of trailer.
Roger that. Level off here. Okay, bogies jinked back into me for the fourth time. I'm coming back starboard. Come back port now. Port, 27 miles. Bogies at 7,000 feet.
45.
Watch out, bogies 13550, Angels 16. Heading 340.
Okay.
Roger, same bogies.
You're in collision now. Steering.
Okay, bogies have jinked back at me again for the fifth time. They're on my nose now. Inside of 20 miles. Master arm on, master arm on.
See, good light.
Good light.
Okay, centering up the T. Bogey has jinked back into me again. 16 miles, center the dot.
Say your Angels.
I'm at Angels 5, nose up.
Oh, his Angels.
Oh, wait a minute.
Angels are at 9.
Alpha Bravo from 207.
13 miles. Fox 1, Fox 1.
Oh, Jesus.
Beacon right.
Roger that. 10 miles, he's back on my nose. Fox 1 again.
Watching them up.
6 miles, 6 miles.
Tally 2, tally 2. Turning into me.
Roger that. 5 miles. 4 miles.
Okay, he's got a missile off.
Breaking right.
Good hit on one.
Roger that. Good kill, good kill.
I've got the other one. Select Fox 2. Select Fox 2. I got Fox 2.
Coming hard, start.
So fucking shoot him. I don't got a tone.
Got the second one.
I got the second one on the nose right now.
Hey, I'm high cover on you.
Lock him up. Lock him up. Man, shoot him, Fox 2. I can't, I don't have a fucking tone. So what? Good kill.
Hey, good kill. Pilot ejected. Pilot ejected.
drifted out of the second one.
Okay, Munster, let's head north,
Okay, port side, high, I'm coming down hard.
Roger.
Roger that. Just either going north, let's go down low, on the deck, unload, 500 knots, let's get out of here. Okay, 2 good shoots. We're showing 2 good shoots in the air here from Munster. Roger that, I see the...
I got the splash, 1 splash.
1 splash.
Taking it down to 3,000 here, Munster.
The splash 160 at 96. Let's go, Munster down to 3,000, let's get out of here. Run north on your right side.
Roger. The other chute is high up, just to the right of the first splash.
We got good shoots on all of them. Roger, 2 floggers, flash. Closed out, we're heading north.
Okay. There's Munster, he's over on the right side.
Camelot's bogeys on the nose, 12530.
Bravo is closed out.